So there are a few more things, interesting things happening in this specific sector as well, and I would like to know what is your opinion on this. Right now, there are works happening on, like you mentioned, and entrepreneurs are doing these works. There are works happening on making analog computer a reality. Then there is
Yeah,
quantum computer which people are trying to work on, which
yeah.
something will be one of the big thing because of the way how quantum computers work and the kind of computational ability they can bring in. So and few other experiments are happening as well, which I can't recall right now. But there are these innovation or that attempts are happening. Like there are people who are there's this there's just I guess a few months back there was this research published in South Korea, I believe, wherein the researchers said that it probably is possible for us to create superconductors on a normal temperature, which again brings back to feasibility of quantum computing, more realistic thing, but which never really happened. There were some other applications as well, but the point is this: people are trying to push quantum computing, analog computers into picture as well. How do you see these systems and electronic based system that we have right now, which is a digital system, competing with each other, competing with them, and what do you see? How will the future of computation will look like?
Mm. You see, these systems have existed in the past. If you recall, in school, we were taught these three type of computers: microcomputers, mainframe computers, and supercomputers.
Right.
Based on application, the markets have existed. It's
Yes.
just that in microcomputer segment, because of our demand, we are further crossing the boundary of mainframe and microcomputer. But yes, for systems that involve calculations to be the very fundamental of requirement in terms of weather calculations, you see, we utilize systems for orbital mechanics of satellite launch and trajectories. Therein, we don't want a fancy graphical user interface. We don't want animations. We want
Okay.
that system to do complex calculus over due course of time at lowest latencies. In factories, we don't want system that can do complex calculations, rather that can prompt us in microseconds of any fault that happens and take mitigative actions. So it varies based upon the application at the moment. So all of these architectures are being explored, or these implementations of computers, based on their very relevance of domain. Quantum computers for commercial market doesn't make sense at the moment. However, it is a boon for complex calculations. The reason being, currently we operate on this concept of binary numbers.
Right.
So binary numbers are more, if I give it context, represented in 0 and 1. In terms of coin flipping, head may be 0 and tail may be 1. Quantum computers are operating on phase of any electron. There's this magnetic quantum number that influences the very operation. In terms of coin, when we toss a coin, so what we are observing is not head or tail. We are now observing how much of it is head and how much of it is tail. And based upon our ability to capture the position at that very moment, we are able to get resolutions of bits known as qubits, quantum bits. So that
Right.
is giving us number of, let's say, if we have a qubit that has capacity of 4. So our single bit was able to represent 0 and 1. Now we have capacity from 0 to 16 to be represented onto that very fundamental. In my macrocosm, even a binary number is able to do teraflops of calculation. So such qubits can extrapolate it to octoflops of calculation, and that is required for systems like weather prediction, for satellite maintenance, for orbital mechanics, as I've mentioned, rocket
Right.
dynamics, to name a few. As of our commercial application, and this is one thing that I would like to optimize onto your suggestions. NVIDIA doesn't utilize x86 architecture. They are in a different game altogether. They are working on parallel computing systems. So again, that are more of a graphic cards. What they do is they perform fundamental calculations of addition and subtraction that is done over an array of units. So their
Mm-hmm.
architecture are simple in of implementation, but they are cascaded in multiple arrays.
Okay.
What x86 is doing complex set of calculations over a given span of time. To make it more sense, the video that we are seeing right now, it is more or less doing fundamental operations of addition and subtraction of colors. However, what makes this video transmit over a particular channel of uh, media, internet that is transmitted over Ethernet or Wi-Fi, that involves encoding, that involves complex calculations. That's where processors come into play. So graphical processors were more of from NVIDIA, and the central processors were more of from companies like Qualcomm and Intel. So
Okay.
application specific architectures are being explored. So speaking of analog computers also, they have a very niche domain that would be catered by their implementation. So we as consumers, it's good for us to have a literary knowledge of them. But yes, they won't be that much beneficial for us as an end user in commercial electronics. So that's how I would like
So,
to put it forward.
what do you think? Where will analog computers be used in future? You mentioned
You see,
quantum.
yeah, analog computers are required for very tasks wherein quality or fidelity is required. You've seen this movie of Christopher Nolan, this called Oppenheimer.
Right.
Yeah.
Yeah.
So there was this very buzz around that 70 millimeter film that they were using. Now the question should be, we live in the digital world. We've got encodings of 180, that is 1920, 8K resolutions are encoded onto our displays.
Right.
And despite of that, he's using an analog way of recording uh, media onto a celluloid film of 70 millimeter and projecting it through a semi-analog means onto a screen. So why he is doing that? Because analog systems provide us higher fidelity. You see, digital systems compromise on quality in form of sampling the data. What I mean to say is, assume data to be a river. What digital systems are doing, they are like a spin wheel that is leveraging water from that river on a regular interval. This interval is known as sampling rate. So if we try to collect that water and flow it in another canal, so that canal would have the water that is flowing in that river, but it won't have the same amount of minerals, the same amount of flow, and same amount of audacity of that water that is being flown. That's how video and audio systems work. And even for other systems that are more, I would say, varied in terms of their representation, these systems, as of their application, require higher fidelity. And when higher fidelity comes in picture, analog systems are easier to implement. To dig deep a bit more technically, and audience, they want to relate, they can also relate to this concept of filters. So there are analog filters and there are digital filters. So what filters do is they alter the pitch of our sound or video. So there are low pass filters that filter out the lower frequencies of sound, and higher pass filter that filter out higher frequencies of sound. Their analogs implementation requires only a resistor and a capacitor, two fundamental components that are easily available in market. However, their digital implementation requires lot of calculations that are exponential in nature, that involves calculus, and that is represented on multiple transistors onto our uh, computing unit. Again, uh, analog systems were better. They utilize less power, but still, our application was centered around that single monolith. So we utilize digital systems. But then for individuals who need higher fidelity, they can utilize analog systems, though might be bulky, though might draw a lot of power in larger sense. But yes, quality is being delivered, and that's why analog systems, analog computers altogether are being implemented. So that we need not to create a whole canal out of it, do our computation, and put the water back into the river. And
Mhm.
on a lighter note, there's this video that was trending ahead. This process, what it can cause problem, or what has been causing problem lately is uh, this compromises a lot on quality and distorts our output, and even sometimes can overflow. There's this one video I believe you might have also seen, a Florida beach wherein an individual dig a canal between the two ends of ocean. So that
Okay.
canal went haywire, and a whole island was created due to the flow of canal. And that's what would happen, or is happening. Our computational capabilities have exceeded to such a point that if we don't tune in, either we tune in such an extent that we are able to critically balance the fidelity and digital capability of computation, or you'll lose out on quality of the output. And that's why analog computers are required.
Right, got it. And I think because of the fidelity part, and that is one of the issues with, let's say, if you want to work with machine learning models as well, because they
Yeah.
work on probabilities in a way. Um, Using analog computers might make more sense as compared to digital computers because they can easily, store that information and train the models as per what is required, and less computational power will be required to do that as well. So probably analog computers can be used in that field as well.